So we currently have, I'd love to pass on to Dr. Jeremiah, who would be guiding us on a technical practical session today. Dr. Jeremiah, are you available now?
Yes, I am. Thank you very much.
Fantastic, thank you. And please, you can continue.
Okay. Good evening, everyone. I'll be doing a recap session, majorly of how to write the methodology section again, and how to write the quotes for your papers. So before I begin, I would love to share my screen. Um, Give me a few minutes, please. Please, can you see my screen right now?
It's coming up.
Hello.
No, your screen is coming up.
Okay. Is it up now?
Not yet. It's
Not yet.
showing Jeremiah. Share screen sharing.
I don't know why it's this slow.
What about if you cancel it and start all over?
Okay.
I'll try it again, right?
Okay. How about now?
Still the same thing.
Okay, let me stop and stop and share. How about now? Hello?
Yes.
Yeah,
Yes, the
Okay,
screen is up.
it's on
okay,
now.
so okay. Okay, so I would want to go over the writing methodology and data analysis section again. But I think since we've done that before, let me just go to the data analysis section. So for writing the code for your paper, um, for writing the code for your paper, there are two ways you can go about that. First of all, you can use GitHub or you can use Kaggle. I don't know. I had meeting with some people and I told them this. So you can use GitHub or you can use Kaggle. So for GitHub, I don't know how many of you have a GitHub account. If you don't have, you can create one. You can create a GitHub account. So what a GitHub account is for is you can use it to search for previous code bases of works that have been done that are similar to yours. So for example, let's say you are working on something, probably this overview. Let's say someone is working on Naira volatility forecasting using machine learning model. and you need a code base for these projects that you can follow that can guide you. So how would you do that? First of all, you open a GitHub account. Once you open a GitHub account, you see we have overview here. So this is my GitHub account. So you have overview, you have repositories, you have projects, you have package, you have stars. So what stars means are like projects you find impactful or you find useful that you might want to actually use the code base in the nearest future. So, and you can see the way I listed them. So I have a machine learning project code base in which there are sample projects that I love and I love the code and I would want to integrate that into mine in the nearest future. You can see mathematics, DSC, and all of those stuff. So now let's say you're working on volatility forecasting. Now you can begin writing the whole code from scratch and a whole lot of that, but it might not really you will be slow in some instance. For example, you just won't be able to go fast, and you need a sort of intuition to know how to organize your code base. And since you need that, you need to check for what other people have done. So what you can do is you can just open a GitHub account. Once you've done that, you just type search. So once you type search, okay, you can just type I want to let's say I want to this topic Naira volatility forecasting using machine learning models. So I want to get like a sample code base for this stuff. So I do just come here and type volatility forecasting. So once I type volatility forecasting, it brings an interesting stuff. So it brings code filter by you see filter by code, filter by repositories, filter by issues. What issues means are problems in a particular code base, filter by pull request, discussion users, and all. And here you can see 547 results, and it's sorted by best match. So let's say I want to sort by the most stars. The most stars means projects that have been starred by people, meaning the project is actually top notch or something. So if I type most starred, I see what I get to see is I get to see a whole lot of different code bases on on my particular project, which is volatility forecasting. So this particular guy, Shibui 191, did a Bitcoin volatility forecasting project. And look, I'm doing Naira volatility forecasting project. So it's similar to what I'm doing. Like there's nothing new under the sun. So you have to leverage on other people's work to see what they've done and just improve on it. So then I come here. After I come here, I look at his main branch. I look at his README. This is the author's name. Okay. Bitcoin realized volatility forecasting. He used GACH and multivariate LSTM. That's nice. So now I look at his repository directory. I look at how he ordered his work. Right. He created a README file. This to explain the project's use case, the methodology and finding. Then he created two Jupyter notebook, one for exploratory data analysis, another for report notebook, another for performance, for presentation, and for all the images that were generated during the coding project. So these are all of it and all, but I need the Jupyter notebook file, right? Because I want to see his code base. So what I'll do is I'll scroll up, scroll up. So I'll come to notebooks, right? Come to notebooks. He did this 4 years ago. So once I come to notebook, I want to see his exploratory data analysis. I want to see what he did. Wow. So it's a whole lot. There's book one. Let me open book one. So once I open book one, you would see his whole work. So once it opens, then you can structure your work according to this particular work and you can decide to improve on it. Well, I feel the book is actually heavy. The Jupyter notebook is actually heavy. So it will definitely take time to load. Um, okay, coming. Let me see if I can open in a new tab. Sarah, software company on GitHub. So you would see the Jupyter is all code based, and I feel all of you should open a GitHub account. So once you open a GitHub account, you can look at sample code bases of works that are related to yours. So it will give you a direction. It will give it you would know what to do next, and a whole lot of that. So it's still opening. I feel it's code bases. It's code bases. Let's see if this would open. So once it's unable to render code block, uh, probably he has moved these files away from here. Okay, that's fine now. That's fine now. Okay. Let me check this. I need to open the Jupyter notebook. So you would see how you can get sample code bases for your work. So you can actually work on that or improve on that. It's taking so long. Okay, I think let me try another. I don't know why this particular work is taking so long. So okay, let's say let me use a quantum versional autoencoder. So let's say perhaps I'm working on that. Quantum VAE. So I want to see the sample projects that have been done on quantum VAE. So right now you can see that people have done several stuff on quantum versional autoencoder before, right? So let me open the link in a new tab. So once I open, I'm going to open the Jupyter notebook file so I can see the sample codes. Okay, this person also has one. Let me see if I can open. Okay, so right now you can see a code base here on quantum versional autoencoder. And now this is a topic for someone, quantum versional autoencoders for inverse design of high temperature polymers. So you can use this as a template for your code. The first step in writing your code is you have to import your libraries, right? So you can just start with a template from GitHub. So, and I would advise when you are writing your code, you should write it on Google Colab, especially if you are paired with another person, because it will enable cross collaboration. So once you open a Google Colab, you open Colab. So once you open Colab, you can start up something. So let me start with this quantum VAE, right? Once you open the code, once you open a sample code base, you look at it. The first thing you would need to do is you need to import the package that particular code base used. So that's the first thing you would do. So okay, once you look at the code base, you studied it. Okay, you look at the whole stuff the person did and all. You look at the person's analysis, right? So you first import the person's library because you need that. Now you have to import your data set yourself. This particular individual imported his own data set from Google, from Kaggle. I mean, yours can be on your system. You need to import that, upload that from your system to whatever IDE you are using to code. So after uploading the data sets, what next? You need to view your data set. Like you need to look at it. For example, you need to look at the head of the data set, input it and change it into a data frame. So once you do all that, the next thing you do is you do your analysis, just like this guy has done. it started visualizing the data. So you can see it did a visualization before it started training, and this was the output of his training, right? So for your topics, if you need a code base, a sample code base, just type that particular algorithm, the particular algorithm your topic is based on GitHub. So once you type that on GitHub, you'll see a whole lot of code bases. So once you see that, you can try looking at what is important and using that for your work. So I'll use quantum VAE as an example tonight. So let's say, okay, let me try to open this. Okay, so some stuff have been done here. So I think this is for Abigail, right? Well, actually, she doesn't have a data set yet. I'm still working on that. So there's a whole lot of stuff that have been done here. Like I said, the first step you will do is you want to import necessary libraries. So she has imported necessary libraries. So she has imported NumPy, Pandas, PyTorch, and a whole lot of other stuff, right? And once that has been done, the next thing you would want to do is um, you want to set random seeds. So what random seeds means is anytime you run your code, uh, I'm coming, seems so. So for this particular code base, you don't impute everything in one coding box. So for example, in this particular coding project, you can see the step one was importation of necessary libraries. So the importation of necessary libraries has to be on a particular code base. So you would have to delete all of these first of all. I'm coming. So nope, nope. So let me. I would have to do work of organizing this. So it will be easy to explain. It'll be easy to explain. Uh, okay, so the first step is importation of necessary libraries. This should be in a particular coding box. So once you do this, you run. So that's the first step. I'm running the first step right now. Then what is the next? So you see it keeps on, it's going to download all of this particular. Okay, there's something. Okay, so it says there's no model named Penny Lane. If perhaps you don't see any model named Penny Lane, just comment it. You will come back to that. I'll come back to that. It also says there's no model named RD kit. So just comment that, you'll come back to that. For any model you can see, just comment that, you don't come back to it. So okay, so the first step, which is the importation of necessary libraries, have been done, right? So now you move on to the next step. Move on to the next step. So The next step is importing your data set. Alright. Since there's a lot of processes on my system today. So the next step is importing your data set. That's the loading of necessary data. But since there's no data yet, like I'm just showing you how you would go about it. Before loading of necessary data, you'd have to set random seeds. Why you are setting a random seed is if you run a machine learning model for 10 times, it can give you different results for each of the time you run the machine learning model. So, and for you to enable consistency, every time you perform an inference on your machine learning model, you need to set a particular seed. And people set it as 42. How that 42 came about, nobody knows. But we all know that 42, you just use 42, right? So just set it to 42. Then the next step, you load your data. Then after that, you now move on to data processing, right? You want to process the data, you want to look at how the data works. And after that, now do your data analysis. So for your data analysis, there is something called univariate data, bivariate data analysis, and multivariate data analysis. I think I have other code here which I can show that actually describes that. Let me check. Check. Let me check. I'm looking for a standard code base that I know that would. Okay. I think let me open it. So you would see the whole process and the whole result of running the data analysis. I think I should open this. Sorry, it's a large file. So while it's actually loading, I hope you all can understand the GitHub process. If you don't understand, is there any question? If you have any question on the GitHub process, you can just let me know.
For me, I understand.
Okay.
Because I already have a GitHub account so that you opened my eyes to how I can use it well.
Okay. Who is that? Is that a very? I don't know. No?
Yes, it's a berry.
Oh, yeah. Okay. Yeah. So any other questions? Any on using GitHub? There are other ways you can use GitHub also when it comes to cross collaboration, all of those stuff with your partner. You can actually use that. In fact, you can use it to write your code, do the whole stuff and directory and all. So, but if there's anyone that still don't understand how to like go about using GitHub to get a sample code base, you can just ask a question right now so that I do go over it again. So you can use it to create projects, your research project, and a whole lot of stuff. Okay. Yes. So this was a research paper done last year. All right. So now this is the code base for the research paper. So first of all, I imported libraries and data. So you can see everything that was imported. You can see it's much. I imported that. So after that, what next? You would have to load the data set. So you can see I did that df like pandas. So for you to load your data, what do? You create a variable. The variable is called df. So once you create your variable, you've imported data, you've imported the pandas library, yeah, as PD, and you have to read your data set. So if it's in CSV, if your data set is in CSV format, you say pd.read underscore CSV. Then provide the path for your data set
Excuse me,
and
Dr.
choose the
Jerry.
delimiter. Okay.
Yeah, I just want to bring a suggestion. Since this is the
Okay.
second example you want to show us, I
Okay.
will kindly appeal or suggest that you pick a topic related to any of us on the call here, and show us instead of us using something that is entirely not our topic. That's just my thoughts.
Okay. I think um I used the quantum VE topic, but I thought that was sort of advanced. So that's why I changed it to this because this is more relatable.
Okay.
Yeah, this is not relatable for people to that is not really relatable, but this is actually more relatable to what I want to explain. So that's what I
Okay.
felt. Yeah. So you see, for every data set that you would use, for every data set that you would use, first of all, you need to view that data set in your code base, right? How do you view that? You do a df.head, as you can see here, a df.head. So what a df.head would show you is it would show you your whole data set, right? So you'll see the whole data set, you'll see your variables and all. So then you do a df.tail also. The df.head will show you the first 5 columns of your data set, like the first 5 number. The tail will show you like the last 5 or the last 10, depending. So once you do that, after importing your libraries, after loading your data set, the next step is your data processing. And how do you do that? You want to get the information about your data. So how do you do that? You do a df dot info, like I did here, right? So it's to show you information about your data. Then you want to know the shape of your data set. So what the shape of your data set means is like you want to know the number of variables in your data set, and you want to know like the rows and columns of your data set. So it's actually going to show you that. Then you want to check your columns. You want to check if there are unique columns in your data set and the number. Then the next step is your univariate analysis. That's your data analysis. So for your data analysis, you want to do a univariate analysis. You want to do, apart from a univariate analysis, you would also want to do a bivariate analysis. Apart from a bivariate analysis, you would also want to do a multivariate analysis for your data set, right? So in this particular code base, I did the three. I did both a univariate analysis. So what a univariate analysis means is you are using one variable for your analysis. So for example, for this, I plotted an histogram of age, like of the age of patients, of the age distribution of patients in my data set. So because I'm using a single variable, that's why it is called a univariate analysis. So examples of univariate plots are histogram, box plots, KDE plots. You can search that on Grok or LLMs, like what are types of univariate plots I can use for my analysis. So once you actually type that, then you would ask maybe Grok or DeepSeek or OpenAI to give you the code base for that. So it will give you a code base for that. Then you can copy and paste it, or you can write that yourself. So I'm going to share this on the group, so you can use this for your data analysis format, both the univariate analysis, the bivariate analysis, and the multivariate analysis. So once you do this, you'll be able to actually create a data analysis section for your research paper, and also you would have the visualization for your research paper. So after my univariate analysis, I went further to do a bivariate analysis, right? So a bivariate analysis is you are using two variables for your analysis in your data set. And what are examples of bivariate plots? We have pair plots, We also have box plots here, and we have other plots. There are a lot of plots. So then I now went for that today, multivariate analysis. So what example of multivariate analysis? It means you are using a whole lot of variables, right? So, and examples of plots for multivariate analysis are scatter plots, violin plots, right? And a whole lot of other plots like that. I don't have this particular data set again. Assuming I had it, I would have just run this and you'll see the whole stuff, the whole results coming out and how. Then after you do your analysis, the next thing is you want to create your model and predict your model. The first thing you do is you want to split your data set into the independent variable and the dependent variable, right? So the dependent variable would be a particular variable that you are testing. Then the independent variable is what you are testing that dependent variable against. So this topic was calibrated machine learning for disease diagnosis. So yeah, I think we were trying to know if patients were either overweight or underweight depending on certain variables. So for example, let's say a patient partakes in sedentary lifestyle and all of that. You want to know if that patient will be overweight or underweight. But what we are actually testing is we actually want to know if the patient would either be overweight or underweight. So that's our dependent variable. So that means all other variables in that data set, they are actually leading to, or they are sort of testing, they are like a pointer, a sort of indicator, or let me use a particular word. They call them feature variables. Like they are feature variables. And we are using that to predict a particular variable that's called a target variable. So your dependent variable is also known as your target variable in your data set. So this overweight is my target variable because that's what I want to predict. But for me to predict that this patient is overweight, there would be some features in my data set that I would use. Those features will be known as my feature variables, right? So that was what I did here. So you split your data set. Once you do that, you would want to scale, you might want to scale your data set and normalize your data set. So why are you doing this? The thing is, first of all, before you even load your data set, you have to check that particular data set because in statistics, there is something that's called outliers, right? And for you to prevent outliers and for you to have a good accuracy for your model, you have to scale your independent variables or your feature variables, scale them and normalize them, put them between zeros and ones, so that it will give you your accurate value when you are testing your model and all. So once you do that, for some particular data, you might want to apply smooth. So why are you applying smooth? Smooth is for class distribution. So now, what smooth means in machine learning is I don't know how I can break that down, but it's actually a way to address imbalance classification. So for example, your target data and your feature data might not be balanced. So let's say for like there might be a whole lot of variables in one particular class and there are lesser variable in another. So you want to make sure that one particular class that you're predicting doesn't have like an advantage over another. So you want to make sure that at least they are the same. Like what you're actually trying to predict, your feature variable, your target variable, you want to make sure they are balanced. You don't want any imbalance in your classification. You want to make sure there's no any form of minority class sample. So like you want to enable a balanced class distribution in your data set. So and for you to do this, you need to balance it. And smooth is a way of balancing the classes in your data set. So this is not compulsory. This is just based on the research work you are actually doing. So once you do that, you move on to predicting your model. So once you predict your model, you get your result and a whole lot of that. And once you do that, you are done. You are done. But the thing about prediction of model is it is based on your research topic. So for example, if you are working on this topic, this by Latif, if you are doing a Naira volatility forecasting, you know that what the kind of model you'll be using is different from the normal prediction models that I used in here. If you're using GAC and all, and I've told you go to GitHub and look for sample work that have been done, then build on that. So that is just how you do your data analysis for your research projects and all. So now I would send this I'll send this particular IPMB file to the page if anyone wants to like base their code on top of that, especially people that will be doing something similar to this. But apart from that, I want to sort of show you how to how to structure your data analysis code base, right? So you can use Grok. I think this will be the last part of the class. So let's say, let me use a particular topic here. What should I use? What should I use? Okay, let me use this particular topic. Naira volatility forecasting using machine learning model. So let's say I want to write a data analysis code base for this particular research topic. Apart from using GitHub as a template, you can also use LLM as a template. So you can use Grok or any of those other LLMs. But let me use Grok. First of all, before I use Grok, I mentioned earlier that for your data analysis, there are three forms of data analysis you should do, and that's the univariate data analysis, the bivariate, and the multivariate. So I do just come here, okay. Um, I'm working on a machine. This is a prompt actually. I'm working on a machine learning research topic, and I need a data analysis code base. I have structured my code base into I've structured my data analysis code base into a univariate data analysis, bivariate data analysis, and multivariate data analysis. Can you provide me with beautiful plots I can use for this analysis for each of these analyses? So what I did here is, for your analysis, your data analysis and all of that, you would have to visualize, right? Even after you analyze your data, you have to visualize your data. And that's part of the diagram that will be in your data analysis section. So, and for you to visualize your data analysis, you have to know what kind of visualization plots are available for each of the analysis you are doing. So the prompt I wrote here is giving me 10 different plots that I can perform for each of these analyses, first of all. So once I run this, so it's going to provide different plots I can use for each of the type of analysis I'll be doing. So for univariate analysis, so it's mentioned I can use an histogram plot, box plots, volume plots, bar plots for categorical data, pie chart, density plots, rock plots, strip plots, and so on and so forth. For bivariate, the same thing. For multivariate, it also gives me plots I can use. So now, once I've done this, the next step I would I would I would perform is I would give it my topic. So okay, so this is my research topic, right? Naira volatility forecasting using machine learning models. Provide me with I can use for this research topic for the univariate, bivariate, and multivariate analysis. So I gave it my research topic. So and I wanted to give me like the data analysis plot I can use, right? So the first stuff, it said I can use a time series plot. I can for my data analysis, I can plot a time series um plot. I can do a box plot. I can do a histogram. I can do a volume plot. So for the bivariate data analysis, I can do a scatter plot. I can do a line plot. I can do X-bin plot. I can do a joint plot. For multivariate analysis, it said I can do this. I can plot an heat map and how. So once it has given me that, what's the next thing? The next step will be for the univariate analysis, help with a sample template Python code for number one. That's time series plot with rolling volatility. So for number two, just keep on like that. Histogram with KDE for returns. For number three, box plot of monthly volatility. For number four, cumulative distribution function of volatility. Don't know why this has not. And for number five, violin plots of volatility by period. Then I would tell it to provide detailed comments for each code samples so others reading my code will understand. Then I click on this. So you can see for the time series plot, it's rolling volatility. It generated the plot. You don't need to copy all of these import pandas and all because you would have imported your library, you would have generated your data set, you would have created your data frame using pandas. You would have done all of the stuff. The next thing you just do is to get your plots. So once you get your plots and all, and you plotted that, then you display. And below, it's also commented, like it gave a comment explanation on what this code is doing, right? So it did that for the whole stuff. So you see, once it has done that, you just copy and paste and all. And that's all for your data analysis section. So you do that for your bivariate and multivariate also. So that's another way you can do this. Apart from GitHub, this is another way you can go. So are there any questions? Let me share this link to the page. Are there any questions, please? So I've shared that particular prompt link in case you might want to use that also. Hello? Any questions? Any confusion? Apart from using GitHub to get your
Well,
code base.
for me, I think the fundamental is clear. My question might come when I begin to work on my own work.
Okay.
Everything is clear.
Okay.
That's for
Yeah.
me anyway.
So, okay. Thank
Because
you.
I'm also making use of unstructured data, and that will be my first experience on it.
Oh. Okay. Okay. There's no problem. We can further have a meeting on that. So you can either use GitHub, like I mentioned. In fact, GitHub has a lot of code bases, sometimes thousands of code bases that you can use for your work and you can build upon. Apart from GitHub, apart from using LLMs, another tool that you can use is you can use Kaggle. You can use Kaggle. I think I also mentioned this to some people. So Kaggle also has a lot of data sets, a lot of code bases that you can use for your work. See, that's lots. There's a lot of code bases that you can use for your work. So look, these are code bases. These are code bases. I think I viewed this yesterday. This for those that are doing the volatility research. Um, those that are working on volatility. So this is a coding project. And look, this guy literally went to town. This is on Kaggle. He went to town. He did everything stepwisely, something you can follow, and you can build upon. So you can just look at his work, follow some stuff, then you can now look on what has this guy not done that I can also do to further improve on what he has done. So this is one, right? This is another for the quantum variational encoder. This is another. This is another. I mean, this is another. These are beautiful plots. Another. This is another. So it's all like that. So you can use Kaggle. If you don't have a Kaggle account, you can open one. So this is mine. You can open one. So you see a whole lot of sample code bases in here that you can actually use in here on Kaggle. So Kaggle, GitHub, then what again? You can use LLMs and all. So I think that's all for tonight. I can stop sharing my screen. And also,
Hello, sir.
are there? Hello.
Yeah, thank you for the lecture, sir. I just want to confirm. I believe this also go in line with somebody that is working on probably a sentiment analysis. I want to use the transformer-based model for sentiment analysis. I believe this also goes in line with it.
Yeah, I'm coming. Let me show you. Let me show you. I worked on sentiment analysis some years back, and I used bets. I don't know if I still have the code. Yeah. I doubt it, but can you see my screen?
Yes, sir.
Hello.
Yeah.
Yes, sir.
Yes, we can see your
Yeah.
screen.
Okay. I don't know. I should show you that. I don't know if I might service in Google Colab, but you'll find it on GitHub. In fact, I can see there's nothing you wouldn't find on GitHub, except if your work is entirely novel. Apart from that, you should get it on GitHub. So you said sentiment analysis, right? Anna,
Yes.
let me check. Let me check. Might still be here. It might not be here. Okay. I think. Yeah, so I think I did check here. Okay, it's on transformer. Well, let's check GitHub. So sentiment analysis using transformers, right? So like I
Yes,
said,
sir.
there's literally nothing you're looking for in GitHub that you wouldn't find. It's the only version control system we have in the world for developers. So you can imagine. So, see sentiment analysis on tweets using LSTMs. Okay, now look at this. Financial sentiment analysis with bets. You know, bets is a transformer.
Yes, yes.
Exactly. So bets is also known as bidirectional encoder representation transformers. So you can see FinBet. This has 1.6K stars. So you can imagine. So
Wow.
even the data set was even there, right? Training the models and a whole lot of that. The notebooks, look at IPYNB 5 years ago. So there's nothing look at example notebook. There's nothing you're looking for on your work that you wouldn't find on GitHub. I can assure you of that. So you can see they use a pre-trained model for this. That's the bet based on case model. Then all what they did was they fine-tuned. That was just what they did. Yeah, they're optional. And they trained the fine-tuned model and they predicted. Look at. So we're working on sentiment analysis, working on transformers, working on a whole lot of stuff. There's literally nothing you're actually working on. You'll rather find it on GitHub, Google Colab. In fact, if you want to use transformers for your project, I can send you this particular tutorial to use. So there's literally okay, yeah. So this was I think this was during 2020. This was during 2020. Yes. So it's also natural language processing using LSTM and bits. So it was like a sentiment analysis. Yeah. So I can send you this particular code base. For this, I use auto visualization. Eh?
I said I will appreciate that, sir.
Yeah, so there's literally nothing, there's nothing new. You would see it on, if you don't find it on GitHub, you'll find it somewhere else. Find it somewhere else. You find it on Kaggle. You see that a lot of things has been done. So for sentiment analysis, for transformers, for everything, you just check GitHub. Just check GitHub. I can assure you, you would find it. You'll find it there. Look, over 100, 137,000 results. You can see it's even so much. So you would definitely find what you're looking for. So other question? Any other question? Like you can see this a curated list of sentiment analysis methods and their implementations. So you can see if you want to do something new, they have even open source implementations for this in different code base, VIDA, sentiment analysis, and all of this stuff. So you will definitely find, and once you notice that okay, you love this, then you just come and you start it. So once you start the particular project, you check your profile. Once you check your profile, you check your stars. Once you check your stars, look at what I just said. It's there already. You can start as much as possible depending on what you're working on. That's on GitHub. And once you are done with your work and all, and you need a job opportunity, then you can post it as a pinned project. Post it as a pinned project on this thing. So once you do that, I think that's all. So any other question?